Yeah, I mean, it's great to see a developer conference here in Cork and such a great turnout. I just think it's definitely it's really great. Especially for us in security, we often go to security conferences and talk about security things, but you're kind of telling the same thing to the people who know it already, when actually it's the developers that you want to evangelise to kind of build security into their software. So it's great to see so many people here today and to be able to talk to you about some of the tools and resources that OWASP can provide to hopefully help you to build silver software. Well, when I say is it mostly developers here? Yeah. Okay, that's grand. So I've got my audience anyway, so I know who you are. So so I'm Fiona, this is Darren, Fitzpatrick. Have any of you actually heard of OWASP before? Are you aware of the organisation? A few of you have anyway, so I'll give a rough overview in a little while anyway about it, so you know. I'll kind of introduce the two of us, then I'll kind of, I suppose, go through a little scenario to show why maybe you should care about building secure software, what can happen within an organisation if you don't, how it can go horribly wrong if you don't do it right. And then the two of us will go through some of the different tools and resources that OWASP have that can help you to build secure software. And then we'll have some time for questions at the end, but during the talk, if you have anything, if you just want to raise your hand, we can hopefully address it then. It'll be good to get interactive as well if we can. Just a quick background about the two of us, kind of how we got into security. So kind of similar enough backgrounds. Darren did a degree in IT applications in the IT in Tala, and I did computer science here in Cork. And then we both went on to study, there's a master's in security and forensics computing in DCU, and that's actually where I first ran into Darren. That was a good few years ago at this stage now, and then we both kind of went our separate ways, working ways then. Darren eventually went on and did a second research master's in penetration testing and intrusion detection in a university network. Did I get it right? Yeah. And then I'm in the security field, then there's plenty of on-the-job learning and certifications like the CISP and OSCP and CEH and different things like that you can do as well. So from there then, I suppose both of us have spent some time working in the consultancy field as well, and the good thing about working as a consultant within security is that, well, one thing, you just get something thrown at you, look at this, kind of not much background, not much time to prepare, and you just have to kind of learn for yourself and just kind of think on the fly and go and do stuff as soon as you can and just figure it out, which is always the best way to learn really, like if you kind of don't have too much time, you just have to get on and do it. But also you kind of see lots of different applications, so if you're kind of web pen testing, you see loads of different languages, different frameworks, different infrastructure, and you just kind of you learn about a lot of things very quickly because you're just thrown into so many different things over time. And also then different businesses as well, like financial services, transport, there'll be loads of different types of banking applications, everything you learn the business, and it makes you think as well about not just the technical vulnerabilities in something, but also like the business risk associated with it, and think about how what could go wrong if something does go wrong. So consultancy is great in that sense. I suppose the downside of working in the consultancy then is you're just given an application, you kind of test it at a point in time for a couple of weeks, and you give back a report to the organisation, and you never really see anything more, you don't really know what came of it. Did they actually fix any of the vulnerabilities or not? Unless you're asked to do a retest the following year and you see the same things again, you're like, okay, well obviously you didn't bother fixing it. What are we doing here? You kind of feel like you're wasting your time maybe a little bit. So then we both ended up then kind of moving more to like an in-house organisation, and we're both actually working Qualcomm in Cork now in different roles. But so that's kind of bringing it back in-house. So it's on the pen testing team within the organisation, but also you kind of get to work a bit more closely with the developers and kind of helping them work on the remediation and give them recommendations on things they can do to build a secure software in. Security into the software. So it's nicer from that point of view, kind of being in-house and being able to work a bit more closely with the teams that are actually developing the software. And I've actually moved on then kind of more onto the threat detection team, so I'm kind of on the incident response side as well, so getting to kind of bring the skills learned from kind of being a pen tester, like seeing how a hacker works and attacker works, and then to kind of detect those attacks actually happening if they do happen on your network, and building control then to try and prevent them, but detecting them when they do happen again. So that's kind of an interesting the other side of it as well, to try and have your kind of intrusion detection and incident response if something actually does happen. And then you kind of work then again to try and build your controls in to stop something from happening again. So it's a good, interesting life cycle. So OWASP, a little bit of OWASP then, for those of you that don't know, it's a global organisation kind of to evangelise software security and kind of help have secure software around the globe. It's all voluntary, so there's a small staff, there's about 10 staff members or something, but for an organisation that has thousands of people that volunteer and get involved around the world, you know, they need a couple of staff to actually run it, but the bulk of the work is done by volunteers in various different guises. So we're going to go through a lot of the tools and resources now, so some of them are lists, book, guidelines, checklists, loads of different things that developers and testers can use. And they also, so there's chapters then, so local chapters within, there's 3 chapters in Ireland: Cork, Belfast and Dublin. So each region kind of has its own chapter. Sometimes it might be split to a country, and then if there's a need for it in the city, they'd have it there as well. And those chapters then would run kind of bigger conferences as well. So there's kind of, a country might run a conference, or else every year one in America and one in EU, there's kind of much larger conferences then. And they're great events. They were just up in Belfast about a month or so ago. There was the AppSec EU was run up there, and I think it was very successful. It was the biggest OWASP EU conference they've been so far, so there's like 800 people at it or something like that. So they kind of have a few days of trainings, plenty of workshops, seminars, then the 2 days of talks as well. Under the kind of 3 tracks that OWASP works under is kind of the builders, the breakers and the defenders, so the kind of resources that they have for all the 3 kind of areas. And yeah, so I mean, most of the things that OWASP provide are free to use. All their software and tools are all completely open source. Anyone can use them within their organisation. And it's also everyone's free to contribute as well. So if you ever do use their tools and think of a way you can improve it or would like to get involved, you know, they're always looking for more volunteers to help out. So everything's kind of free and open. So I think probably the only thing they charge for is the conferences, and all the meetups and everything like that are all completely free. So. It's a great organisation.
The only problem with the open source thing is that not everything is perfect. There are some, there's 1 or 2 flaws here and there. You might get some spelling mistakes and stuff like that, but you can't come crying to anybody. Like if you're paying for something, you can't come crying back, because it's just lots of free people that just did it for the good of the world of security. So
all you do if you see the problem is get involved and help fix it.
Exactly, that's the thing.
Yeah, because everyone's doing this in their free time. So yeah. And then quickly about OWASP Cork, we set up in about 2014, and we've run a series of workshops and chapter meetups and presentations, talks. We've done a series of workshops on some of the tools, the top 10, and how to kind of detect those within your applications a couple of years ago. We haven't had a meetup in probably about 6 or 7 months, I say, at this stage, but we're kind of looking to organise the next one as well. And we're always looking for new speakers as well, so obviously if anyone has something they'd like to share, you know, we're always looking for people to come and give a talk maybe about how you build security into your applications or something like that. So yeah, I'm just going to tell you a little story now, maybe that hopefully kind of show you why you should care about building secure software. So I'm going to tell you about a fictional company called Acme Corporation. We're a pharmaceutical company, and you know, we're scientists. We kind of wear our white coats and we kind of do lots of research. We're actually trying to develop a patent at the time for some new tablets, medications that we thought was good. So obviously there was a clinical trial and medical records involved in this, but you know, we kind of sat in our lab kind of working away with a small IT department. There's kind of 5 or 6 of us doing various bits and pieces. We set up some email servers, different things like that. Got an audit one day and they kind of said, oh, I think you should probably have passwords on some of your systems so you know people can't get in. And so we kind of implemented passwords, but no one really likes trying to remember those things. They're a bit complicated sometimes. So we just kind of put them on post-it notes and stuck them around the office, and we shared the passwords between everyone. You know, it was fine. We passed the audit then because we had passwords on it, so everyone was happy. And one something that, you know, we didn't want to, we had putting all our funding was going into all this research that we're doing, so we didn't bother. We didn't have that much money to spend on our IT system, so we wanted to build a website where we know we could maybe collate some of our research data and show it out, and you know, so all this, the people doing the research could enter the information in there. So we got an intern in one summer and he developed a website for us, and obviously where the user has to enter in the patient data, you know, we put a password on that, and it was fine. They could do it at home, so it was nice that they could do it from home and stuff like that. So we're all happy out, and we're kind of close enough to getting our patent out, and very busy working until one day we got a phone call from one of the people that were involved in the clinical data trial, asking why all their information was up online, their medical information, all their records were there, and no, they're not, you know, we wouldn't put them up on the internet at all. And let me look into it and I'll get back to you. Anyway, a while later, we kind of spent a bit of time. It took us a while to investigate it because, you know, we didn't really have the skills, but we spent a lot of money actually on a consultancy firm to come in and help us determine what had happened. But it turned out that, there's something, SQL injection maybe, that we had this database, and we didn't do something properly. This intern, I mean, he was supposed to do it. We asked him to make it secure. He didn't. I know that's not our fault, is it? He said he would. But anyway, they got this SQL injection thing. I don't know, my daughter tells me injections aren't very nice, so I trust her. But anyway, so the customer data was leaked. We had to spend a fortune on responding to this incident, and I mean, we lost all our research data. Some other companies stole it and they went off and made the patent before we could, so we kind of lost a lot of money there. We lost all our trust, and the data protection commissioner came after us as well, because obviously we were supposed to be protecting medical data and we hadn't, so that didn't really work out too well for us. So we kind of didn't really have any money, and we kind of said, okay, well, round 2 now, I suppose if we're going to be doing our IT systems, how can we maybe build them a bit more securely? So I started looking online for some resources, and that was where I found Darren and the guys at OWASP.
So that sounds like a pretty bad situation there, Fiona. Luckily though, there are some things that you could do to make things better, or make it less likely that these types of things would happen in your security model. So the best thing to do is always to bring security in from the very earliest stages. So you're thinking about it right from the start, from design all the way through to implementation and beyond, so even after the application is deployed. But luckily OWASP also have some free and open source tools that can help you to do that at every single stage of your development lifecycle. So let's look at a few of them here. First question is probably on your lips is, where do I start? Because there's so many projects. I go onto the OWASP website and there's millions of things, and some of them have more contribution than others. Some of them are bigger and more well known than others. They do rate things. Mature is the most fully fledged projects with the most work that consistently goes into them. But there's just a lot there. So a good place to start, if you don't know much about security, is the OWASP tutorial series. So if you just Google that or search for it on YouTube, you come to a series of videos that will tell you about some of the most common, most well-known issues that you should really know about. So there's cross-site scripting in there, SQL injection, which Fiona mentioned, she had some trouble with. HTTPS is also obviously important to encrypt your data on your website. So a little bit of background on the things that you really need to start on. The next project is one that a lot of people heard about. Has anyone heard of the OWASP Top 10? Hands in here. Cool, a few people. And anybody actually used it in their projects or being forced to use it for compliance reasons or anything like that? Yeah, cool, nice one. So it's out there, it's being used, and it's it's being, as you can see here, it's being updated every few years. It's usually every 3 years. It went 4 years this time. So what it is basically the list of the top 10 most important web app vulnerabilities that are out there on the internet. Important meaning how widespread they are and how much impact they will have if an exploit happens, and an exploit happens that uses that vulnerability. So the one that Fiona was talking about is a form of injection which uses SQL to manipulate a string. So basically the injection happens because your input parameter that you accept from a user, if you don't filter it down to just what should be, like a whitelist of what should be accepted, and you accept characters like single quotes and equal signs and stuff like that could be in SQL statements, you can manipulate the resultant SQL line that gets then passed to the database. So you completely change the logic of what's actually happening in the database, and you can do things like add in a union statement that actually adds a whole other table to the database, like maybe the users table, and then ask it to give you back the passwords, something like that. Some databases even have access to the operating system built into them, so sometimes in certain configurations, sometimes you can even get the application server or the database server to call back out to you and give you remote control of that server, so it can be that bad in certain situations. So the top 10 is the newest version. The 2017 version is just being released at the moment. It's just being finalized. I think it's out at the end of this month or the end of next month. It's very close to being released in its final form anyway. The changes to it were, there was some merging there was two in it, A4 and A7 there, were basically subcategories of broken access control, so they were just merged into one. Insufficient attack protection was brought in, which is basically, you can see very easily in your application that something's happening out of the norm. So it's kind of can be easy to respond to that within the application by saying, usually I'm only looking for numeric characters in this field, and my JavaScript is supposed to protect me from anything else getting added in. So why is like SQL like characters getting into this field? Obviously someone's trying to do something bad, so maybe we want to respond to that in some way. Maybe blocking them, or maybe that's not always a good idea, but responding to it in some way anyway. Under protected APIs as well is a very common one that we see. Maybe you have a REST API somewhere that you didn't actually document or you didn't link to within the application specifically, but actually if you can get to that, it's still out on the internet, and you can get to that, and maybe it doesn't have the same security controls as you did in the front end of the application of the web server, but people get to it and people find these things. There are ways of finding things that are kind of hidden like that as well, so it is an important one to have in there. So next thing, after you've had some looked at some of the list of vulnerabilities that are most important to you in the OWASP top 10, you might want to get into some more specifics. So the cheat sheets project is a set of really concise listings of the most important things that you should know about lots of different technologies. So there's lots of development languages in there. If you're a .NET developer, there's a .NET cheat sheet. There's Ruby on Rails cheat sheet. There's different categories as well. There's developers, that would be like those programming languages, and things like LDAP is there, LDAP injection protection, so things like that. And then you also have the other categories that Fiona was talking about earlier. There's breakers and defenders as well. So for breakers like me, like that's what I do for a living, I try to break applications. So I'd be looking at things like the XML security cheat sheet, and there's one for SQL injection as well, which gives you like differences in, maybe if they're using MySQL, there might be slight differences in the SQL that you use, so things like that to get it more specific. So once you have that knowledge you've built up, you know all about the different vulnerabilities that are out there, you have some specifics for the technologies that you're using yourself. Next thing you need to know is go to something like WebGoat to actually practice actually attacking these things. This is where it gets cool. This is what I love personally. It's why I got into doing what I do. You get to break technology. You get to try and make an application do something that it wasn't supposed to do, and pull out that data that you weren't able to get to, or weren't supposed to be able to get to, like that medical data, or to just make applications explode basically. It's awesome. So this stuff is fun to play with. But how do you get started? I don't know. Do you go to Amazon.com and start putting in like SQL like queries in there? Probably not, because they're going to be watching. There's a big head nodding down the back, but no, probably not a great idea, because they're going to be doing some monitoring and alerting like Fiona's team do in Qualcomm there, and they're going to probably see what you're doing and possibly respond to it, and they're not going to like it. So there are tools then like WebGoat. WebGoat is an intentionally insecure application, so you load it up, it opens up a port that you can connect to by HTTP, and it goes like, okay, here's A1 injection from the OWASP top 10, and here's what it is. Here's taking SQL injection. This is what it is. This, you put in a parameter here, put in some SQL, and it will break stuff. And here's a form field that's actually vulnerable to that. So you can actually just type your SQL statement in there, try to break out of the context of what the original SQL statement said, and within the page you'll see exactly what would happen in an actual real-life application that has that vulnerability in it. So great place to start and actually just learn. There's a very old saying, know your enemy. It's very difficult to understand what an attacker is going to do and defend against him unless you actually really know in detail the techniques that he's using. So this is where this comes in. Security Shepherd gets an honourable mention just because it's an Irish guy that developed it, a fellow called Mark Dennehan in Dublin, who's on the OWASP board now at the moment. But when he did his fourth year project in college, he wanted to do something for OWASP, so he decided to make another intentionally vulnerable application. There's a few of them out there, so he just decided the slant that he took was he made like a lot of more administration stuff built in. So you can go in and say you're using it for teaching some developers about security stuff. You teach SQL injection. I keep coming back to SQL injection. You're teaching that on the first day. Open up the SQL injection sections of Security Shepherd, and it will bring you through teaching them about that. Or you can flip it in then to capture the flag mode. Capture the flags are another thing that you can use to, once you know a bit about the vulnerabilities and you've practiced on the insecure websites, like Security Shepherd, or you could just turn it into like an actual game where you don't know what the flaw is up front. You go in and there's a parameter, you have to find out what's wrong with it. You might see from an error message, oh, it's SQL injection, so you poke away at it and you eventually get in there. And when you get in, you get your name on a leaderboard then. It keeps a leaderboard, so you can keep track of who's winning basically, and just make it a fun thing out of it. Like we did that in work a while ago. Fiona actually set it up in work, and just to promote a bit of interest in security and a bit of the fun side of security for people in the office, which is kind of cool. So yeah, that's what Security Shepherd looks like. So information about security, or about this thing, which is SQL injection in this case, and the form field that you can just actually put in another SQL statement in there, or that's actually just a full SQL statement, but it'd usually be a subset of an SQL statement because you're trying to continue the one that the application actually has built in and put some comments at the end so it gets rid of the last bits, and basically just break out of the context there of what you're supposed to be doing. Problem with these is that sometimes they can be a little bit tricky to set up. We're not all sysadmins, we might not know all our Linux commands off the top of our heads. So the easy way to do it is to go off to the Broken Web Applications project and just download a virtual machine. I think it's .ova format, if I remember properly. But you can load it up in VMware, you can load it up in VirtualBox, and it will just have all these tools built in. So the ones we were talking about, WebGoat is at the top there. Variations of WebGoat as well. There's WebGoat.net, RailsGoat, Security Shepherd, which we mentioned, is on it, and Down Vulnerable Web App, which we're going to see in the demo there in a little while. There's also some actual old versions of things like, I think WordPress and Joomla are on there as well, old versions that you can actually exploit some vulnerabilities that you will find on the internet. You can just Google like WordPress version, whatever is there, and you'll find out what the vulnerability is, and then just go and exploit it in a real application that wasn't intentionally insecure. It just, like a lot of applications, has flaws built in by accident. So, next thing up is we only need to use a tool like Zap to actually go and exploit this. You can go, a lot of this stuff can be done with browsers and with, especially with like there's a lot of plugins for Firefox. Chrome has a lot of developer tools built in anyway that are really, really useful for this stuff. But Zap it's like a proxy, but a local proxy. So we normally have your network proxy, which says, here's a point on the network that we're going to send all the traffic through. It's going to be a choke point, so we can do some analysis, or we can block traffic, or we can see what percentage of people are using Facebook every day, or whatever you want to use that proxy for. In this case, we're going to use it to actually listen locally and stop the traffic as it's before it gets to the web application. So in this case, this is what the screen looks like in Zap. So it's kind of similar to what you'd see in your standard IDEs for the development stuff as well, so it probably looks kind of familiar to developers. But so you can see things like the headers for a web application might not be something that you see all the time. Like, a lot of developers haven't ever seen these actually. They just rely on certain things to happen based on what APIs they use in their programming languages themselves. But people don't realize things like the server header. This is a response packet now, so we can see the responses there. So the server header is telling us that this is Apache Coyote 1.1. Sometimes they can be they can tell you a lot of information, like very specific to what a web server is there. So again, you can go off and Google that version and maybe have a starting point of something that you can use to exploit that, because there could be known vulnerabilities out there that you can very easily just take and attack within Zap or whatever. And yeah, everything then is, you're going to see everything as it goes back and forth. So hidden form fields are something people kind of forget, that, okay, people don't see them on the screen, but you can actually get to them if you're intercepting traffic like this. Your JavaScript might be stopping certain characters from coming in, but you can just delete all the JavaScript and something like this from when it gets to your browser, and then bypass those controls altogether. So that's why you do need to check stuff again at the server when it gets to the server, as well as just doing it in JavaScript. Just use the JavaScript for the speed side of it, but don't rely on it for security at all. So yeah, there's some scanners then built in, so you can see at the bottom there's some alerts that would have came up from scanning this application. You have active and passive scanning, so you can have your passive scanning running all the time. It's not going to hurt anybody. You can run that on like a production web server, and it's going to be totally fine, because it will just look at normal stuff that's going through and say, like, okay, I see a password field and it's not running over SSL. So, well, HTTPS, I meant to say SSL is broken, don't use SSL. TLS all the way. So you can see that just without doing anything, whereas with the active tests, it's going to take things like for SQL injection, it's going to just try throwing in SQL-like statements and seeing if something breaks out, and then you'll just get an alert down here. There are some false positives, but a lot of time it does find very interesting stuff, and it's very, very good as a starting point and something that you can use even even without a lot of knowledge of what SQL injection is. It's going to tell you like this looks like it probably is. So go off and here's the exact input that we put in, so you can go off and test it yourself and see if it actually does something. So yeah, this is what this stuff looks like. I should have set this to actually automatically come on, but my testing wasn't good enough. I test security, I don't test slides. So yeah, non-vulnerable web app is one of the ones that you'll get to play with if you load up the broken web applications thing that we were talking about. First thing you need to do is set your proxy to go out on localhost 8080 is the default that Zap is going to use. So once you go to that, we're going to go into non-vulnerable web app, log in, admin, user is logged in now. So remember the admin, it says admin is logged in. So we're going to go into the SQL injection section, just put something in. Command execution is going to be on this page as well, where it's just doing a ping, which is, you can even see it's exactly like what will come back from doing this on the command line. So it looks like it's probably taking it directly in. But as we were running those things, a map of the site has been building up there on the left hand side that you can see. So just come in here, click on the active scan button, and you can see that all of the parameters that it finds, including things that you might not think of, like the headers in the application, everything is going to get stuff thrown into it to see if something unusual happens that's maybe looks a bit like it could be a certain vulnerability. So you can see there are while we're waiting, we're just going to go in to look at the options that you can have. You can have a few different hosts scanned at the same time. You can change the concurrency of the threads. You can mess with the delay as well, because sometimes you don't want to bombard a site with traffic, because that might not be a good thing as well, especially in older applications. It's probably not such a word these days, but it does happen. You might want to think about that. Some configuration around the connection. The local proxy is the key thing, because we're listening here on localhost 8080. So that's the thing that opens up a listener, Zap opens a listener on, and you're going to set your browser to go out on that as your proxy. It's a local proxy. So results are in. We got SQL injection coming back from one of those fields. When you click on it, you can see exactly the parameter that was put in. Here's the injection point. So what you want to do is repeat that. You're going to go off and fuzz. So fuzz, it means just throw in lots of data. Find lots of things that might make something extra happen. FuzzDB is what's being used here, which is like a open source, again, set of lists of things that you can use to fuzz the application. So he chose there the MySQL, SQL injection specific stuff, because you could see that was MySQL injection, MySQL that was there based on the error message that came back. So now it's that stuff that was just saved. So yeah, playing around with that, and again, yeah, we can see it's MySQL. Some information you can get based on the different responses that came back to slight different variations on what you entered in, and you can get some information for that. So now, like I mentioned with a union statement, you're bringing in a different table into the actual SQL on top of what was originally being called. So we're bringing in the user table here, and we're going to select the password and the users from the users table, as well as what was originally being pulled into that. So throw it into your parameter and you get some extra stuff that comes out. So admin is there, and the next guy, we're logged in as admin. So we can see that at the end of that, we could just guess it might be MD5 that's being used as a hash. MD5 is, again, not a great thing to use, but it does still get used in the wild. Because you can see it's MD5 being used, you can go off and use the encode to Zap as well. If you put the word admin, you can see that the MD5 hash has the same n few characters, so it looks like it's MD5 that we're using. MD5 does have, because it's it's not the best one in the world to use. You can use things like, there's a thing called rainbow tables, which are basically pre-computed hashes of lots of different words, and usually like even every single combination of characters that you can use. So you can get that on the internet, you can put in your parameter. He was able to find, based on a reverse search of pre-computed hashes, that what the password was for that one, so straight in as the other user. Now he's over to the command injection one, and the main thing to remember in command injection is that if your parameter is being put in directly, it looks like it maybe like your IP address you're putting into that parameter is getting directly placed onto your command line. So it's like, it's just going to say, what was it, ping? It was a ping, so it just goes ping space whatever was put into this parameter. So what happens if you put in an and symbol on the command line? It does this command and the next one after it. So that's what's happening now. All you have to do is put an and symbol and put in whatever else you want to happen after it. So that's what's happening now. And it's a Linux system, so ls is going to tell you a directory listing of the web server, as well as giving you back your ping results. So there you go, help index.php, all that stuff. Let's try some other commands. And we also can do cat the password file, show me all the users on the system. And there we go. That's not very good, is it? So again, cool stuff. I think this is awesome personally. It's really cool to play with. It really will help you to get to know security and to build that security into your application, and it's just fun to do, so why not?
Cool, yeah, so I suppose we've shown kind of some of the OWASP tools that you can use to detect how vulnerable your software is and what flaws might be there, and how you can play around with it and learn to kind of detect these yourself in a safe environment. And then obviously you can use these tools in your own organisation. Don't go and use them out in the wild because you might get the police knocking on your door, as Darren said. But yeah, so the tools there are used for testing in a safe place first, and then you can do it in your own organisation. I suppose you always need to make sure you have permission to do it as well. But so now I'll go on to show you. There's actually some tools then also as well, like the builder type tools and the defenders that you can use to make sure that you are building security controls in once you know what flaws are there, to try and prevent them from happening again. So the first is there's some checklists and guides that OWASP have released. So there's the developer's guide, the testing guide, and the code review guide. All of these are released in book format, but they're in downloadable PDFs as well. So they're just kind of checklists of different things in the different stages, so the development stage and the testing stage of what you can do. The code review guide actually gives you a framework of how you would apply a security code review, the different steps you need to take and what you need to do, and the different language. I think it's mainly based in .NET and Java. There's some C, C++ and PHP modules in it as well. But the kind of things you need to do to look for flaws in your code actually doing a code review. Then the application security verification standard this is a great project. It's a document really, and it's just kind of a checklist that you can use to apply to your organisation to kind of determine what level you're at or what level you need to be at. So there's kind of different levels. So cursory, opportunistic, standard, and advanced. Cursory, we kind of ignore that one really. Opportunistic is kind of you'd apply that to all your kind of standard applications, maybe your external facing website, everything that's there within the organisation. That's not too critical, the information might be too sensitive, but an opportunistic attacker might be able to just kind of get some open source tools, some known vulnerabilities, and attack you based on that. The standard level then, so if you want to kind of get certified, it's kind of self-certifying, but if you want to get to the standard level, the types of applications you might want to consider for that, or ones that have some sort of sensitive information that's not publicly available. And you might be slightly more targeted attack that might be protecting those. And then the advanced level then is for anything that has highly sensitive information on it, like PPI, medical data, stuff like that you kind of really want to have an extra stringent level of controls. So it covers various different areas such as access control, levels of cryptography that you should have, web services, user management. There's 18 different categories, and so then this is kind of an example of how it looks. So within each category then, so this is the web services one. So at the start of the document, it gives examples of, say, your organisation. So say you're a pharmaceutical company, so the industry that you work in, and then your threat actors, so the type of threats that you could expect to come in, so it might be a rival company or something like that want your information. Someone, if you're a bank, someone that might want to get your credit card details, they can sell them on the internet or use them to get money. So who your kind of threat actors would be based on your organisation and the industry that you're in, and then what type of systems that you probably have within your organisation. So your network might want to have might want to be at level 1, your general network. And then level 2 then would be your more critical, it'll define the type of critical applications that would usually be in that industry that you need to have at level 2, and then what type of the ones you have at level 3, and then for each of the areas then it gives a description of the kind of things you should get in place for level 1, level 2 and level 3 for each of the 18 different categories. We've only 5 minutes left, so I'll quick go through. And then, so a couple of projects then you can use to defend your site once it's actually out there in production. There's the app sensor project. It's just kind of a built-in it's a framework for doing intrusion detection within your web applications. So you can detect when attacks are happening and hopefully respond to them quickly and then prevent them from going any further. There's the HTML sanitizer is another project for obviously for cross-site scripting. You might say try not to accept untrusted HTML code from somewhere else, but maybe you have to whatever way your application functions, you have to accept HTML from somewhere else. So this kind of is how you can sanitize that HTML and make sure you're not going to get hacked because of it. And the last one I had was the cross-site request forgery. Csrf Guard, is it? Yeah. Which is, it's just a framework that allows you to build secure tokens that you can try and prevent cross-site request forgery within your application. Obviously, all of these are up on the OWASP website, so we'll just kind of flick through a few of them, but go up there and look at all the different projects. And if some of the vulnerabilities I mentioned there, you don't know, obviously there's information on them in the top 10 and all different things like that. And then, one other one is the Dependency Checker, so if you're depending on other libraries and things like that within your code, that you can just run this and it checks against kind of known disclosed vulnerabilities to see if you're using something that has vulnerabilities built into it, so you can maybe upgrade to a more secure level or something like that. So that's it really. There's plenty there with OWASP that you can use. I hope some of that was useful for you, to help you try stop getting to the horrible scenario we had earlier where you're losing loads of money and you're in big trouble for getting your website hacked. And then the OWASP Guard, hopefully check out our meetup page. We're hopefully going to have another meetup soon enough, so we'll announce it up there if we do have it. And any questions? Our email address is there. I'm not sure the slides being shared, but if you want them afterwards, email either of us. If you want a list of the tools or anything like that, so you can pass them on. But any questions?
You went through a number of different attack points, but is there any kind of guidelines for social engineering and cases like that?
I'm not sure if that comes into OWASP particularly because it's more application-based stuff. So lots of different types of applications, like there's mobile, there's things like lots of different variations on applications, like web services, that kind of thing. But I don't think actually I've seen anything myself on social engineering.
No, so you're talking about say a phishing attack or something like that coming in, or not that, there might be some stuff, but not that I'm aware of anyway, because it would more, I suppose, say if phishing attack got onto your network and then they're on your applications, you'd be trying to detect them. Manipulating your application itself, where if they could get onto your systems, that make them as secure as possible, so limit the damage once they get in, but actually how to protect against that.
The other thing that from social engineering is sometimes applications can be used for social engineering. So Csrf Guard is one of the tools that Fiona mentioned. Cross-site request forgery is where you can make a click on your site, actually do something to another site, or make other things happen based on clicking on your site. So if cross-site request forgery was there, your site can be used in a phishing attack. So it's more from that kind of perspective that these would,
You mentioned ASBS and you mentioned several levels of security in the application. Do you have an idea how these levels of security correlate with the Data Protection Act in different countries? For example, I know you have to protect the sensitive data you were mentioning, pharmaceuticals. There's a level for that. So
it's not really, I suppose, because it's quite open and it's just a framework for you to use within your organization. So it's not an official standard, because OWASP is so free and open source and kind of stays away from vendors. And I suppose it's not something that can be sold and used as a standard. So they've kind of veered away from that a little bit, but the level 3 would be intended to be used in that kind of situation where something was under data protection control, so your kind of highly critical data, which would be subject to that. But I suppose because it's a global thing as well, it's not related to any particular country, so it's going to be different everywhere as well.
A bit of a risk analysis for your own company comes into it as well. Like you're probably going to want to take all of your applications and go, this is the data that's going through it, this is how widespread used it is it out on the internet versus just in on the local network. Lots of those different things come into the level of risk that you assign to that application. And then you probably have, lots of companies have a lot of applications that they will have to get through, so maybe you're just going to do the cursory review on some of them just to get through the first pass of it, and then give your crown jewels applications to level 3 or whatever, you know. So it's risk analysis first to decide, I guess.
So, just in relation to the previous question there, would those regulations or those guidelines cover the new GDPR regulations coming in?
Well, again, it's kind of, I suppose it's up to you and your own organisation to do, like you have to have an awareness of what your data is and then apply the different levels. So yeah, again, it's not something that's really tied into the particular laws in different countries or anything like that. It's just to kind of, once you've classified, say, this is my data that would be subject to GDPR, then you're probably going to give that a level 3. So they're the type of controls then you should apply to it, but it doesn't actually tie into any kind of regions, laws or anything like that.
That's an interesting concept though. Okay, in my head I'm kind of, as you were saying that, I'm kind of thinking that could be an interesting OWASP project in itself, you know, so why don't you go off and start that?
Yeah.
Because that's the good thing about it's open source, people just do it for, if they think it's a worthwhile project that they're interested in, that's totally doable.